Hello everyone, so welcome to Math 126 homework master videos here. And I've introduced some hard problem in section 14.3. In this section, we are still talking about finding the partial derivative of a multivariable functions. This is a part one. Start with number 15. We have a function going to be f x y equal to x to the eighth and then plus 6x times the y to the seventh here. So when you find a partial derivative, it is really s- similar to find implicit differentiation in Math 124. If you find fx, xy, the partial derivative with respect to x, then the other variable is constant. So if you're trying to find fx, xy, x is the variable, y is the constant. In this case, we're just gonna be fine. Okay, the x 8x plus 7 just to use derivative rules learned in Math 24, just apply to it. And for this, x, y, they're separate function. Make sure to use a product rule when finding the derivative of this. So 6s is a function. The y to the 7 is not a function. When finding fy, xy, so make sure to treat x as a constant. The y is a variable. And when treating x as a variable, then the derivative of x to the 8th is a 0 because the the derivative of any constant is a 0. And this one just a treat for x for fxy for x and for the first one x is the variable, so for whatever it says underscore is the variable. In this case x is a variable, t is a constant. So when you do the product rule, make sure the take the derivative and just to treat t as a constant. Then there's ft xt, treating x as a constant, t is the variable. Use the product rule and the chain rule. Okay, this one seems complicated, but do not worry. It's the first thing you see a rational function. They have a fractional form. We call them rational function. Use the quotient rule. And when you find this fx and y, just a treat. X is a constant. Then y is a variable. A, B, C, D, they're also variables. So it just basically is variable and variables in some of the function here. And then for here, fy, y is the variable, x is a constant. And just apply the quotient rule. If you remember all the derivative rules from Math 124, take in fall, and just apply the quotient rule, then use those to treat a variable, just the function method, just to solve the partial derivative. Okay, number 4 is another quotient rule because it's a rational function. W here, so this time you want to find a partial derivative with just respect to u. This time u is a variable, v is a function. No, v is the constant. And then you apply quotient rule, the same thing for this one. So v is the variable, then x is the constant. No, V is the variable, the U is the constant. I'm sorry that I almost got mixed with like X, Y, Z, U because there are too many variables for me. Oh, geez, too been complicated. No worries. Let's move forward. Okay, for number five, this is like the simple product rule here. So it's gonna so this is gonna be used like a logarithm differentiation here. But it seems to be not work, so let me work on this. So it's gonna be number 28. And this is gonna be like a hard one. So I'm just gonna you may just think, okay, I'm gonna use the power rule or logarithm differentiation because in logarithm differentiation you just think it's a function to the power function. In this case we do something it is differently. If y is a constant, use the power rule because y is constant, there's like x to the power is constants. So for example, if y equals to 5, just an example, if y equals to 5, then this is function going to be x to the 35, use the power rule. But if x is a constant, then y is a variable, then this time you must use logarithm differentiation, which is going to be the x to like a power e variable y, the natural log of x. Use natural log for this second one. No, use natural log for second one, and the power rule for the first one because first one when x is a variable, the y is constant, then it's just a single power function. Use power rule. But second one, you need to use logarithm differentiation. Oh yeah, this time you're starting to get this harder. It's like the three variables here. But simple rule: if they're asking for x, y, z are the constant. And now you do need to chain rule and product rule. So when asking for f of x of the partial derivative, x is a variable, y, z are a constant. And then for y, it's just the y is the variable. X and z are a constant. For this, like z is a variable, x and y they're constant. This is the same thing, but just a more product rule and a power rule. More product rule and power rule, just the same thing. This for this fix y, just treat x as a variable. Y z's are constant. This one treat y as a variable, x z they're constant. This one z is the variable, x y they're constant. This was like seems familiar, right? If this one is actually from a partial derivative of x, the x is variable, y is a constant. This time is gonna be the power rule because y over the because when x is a variable, the partial derivative y and z are all the constant. Constant over constant is also a constant. It's still constant. And so it's a number. So first one just use the power rule. And then for next two one, because the y and the z they're inside just like a power in the exponent. So use logarithm differentiation. First one power rule, second, third one logarithm differentiation. Okay, I will put this on midterm to review because this is hardly gonna only like a final or it's like a midterm. So I will just leave this alone. Okay, so this time it is just so it just gave him point at a partial derivative. So what you should do is like They're finding for x and y. So x is a constant, y is a variable. Now your first step is due to use the chain rule and the logarithm differentiation. No, chain rule and the product rule to find the partial derivative, and then put x equal to 2, y equals 1/4 or 1/4. That is your answer. Thank you so much for watching. This is gonna be the 14.3 part 1 homework videos. I will make another homework video for part 2 later today. Hope you guys find helpful and have a great day. Thank you guys for watching.